started out with the ball shooter, kind of like previous team. Yeah. And we didn't really enjoy the way it shot it out. I wanted to do something different because everyone seemed to be doing that at the start, and everyone did everything else. So we went straight to the catapult, kind of like this. We initially made this, but the only difference was this was supposed to shoot the two orange fangs, like they stuck them together, so it's not a ball. So we had to modify it, and so we went and we made like a claw, which didn't work because it shot straight up, and then Oliver finally got the claw to work. Yeah.
What are you doing? Go back. All right.
Thanks.
Are you done?
Yes.
Okay. Go ahead. Okay, so lack of communication. Okay, so this is obviously finished design, and to get from the original design to this, we had to make a few specific changes. So go ahead and go to the next slide. This is just a close-up of the weight and that whole system. But this right here is basically the life of the contraption. What would you call this, Mitch?
A winch.
A winch. Okay. Basically, how this works is we have two motors. It's over here, it's over there. Two motors, one on top, one on bottom, that powers the wheel, which is attached to the string, pulls the arm back. Simple stuff. The cool thing about this, though, is if you pull back on it, it releases tension from the motor. So basically, what's keeping it from firing right now is the motor itself. And when you pull it off of that, it allows it to spin. It keeps it from back driving the motor.
Yeah. Driving the motor.
And so that is basically the life of the entire catapult. Go ahead and go to the next one. And this is the loader. Yeah. This actually does two things. It loads the ball and it fires the catapult, because like I said earlier, something has to pull this off of the motor to work, and it's already using two motors, so we had to multitask with this one. There's a motor over here, as you can kind of see, and it's attached to, can't see anything.
Yeah. Kind of like a rocker.
Yeah, so it's got a claw that rocks back and forth. You'll see it better when it fires. It's not really hard to explain, it's just confusing. So you can see it right here, and it just rocks. So it rocks, one ball goes, and that arm comes up and keeps the next one from going in. So the whole thing's on an angle. And then there's an arm attached to the motor too, and then a string attached from that to the winch. So what happens is once it goes past the point where it releases the ball, it goes a little further, the ball goes into the arm, and the string pulls the winch off of the motors and it fires. So that's how that works. We're gonna go to the program now. If the email shows up a minute ago. Yeah, we're going to show you the program in just a second. My email's up on the screen.
One thing we ran into for issues was how to get to release that energy. We went through many iterations. One time we had a differential, which basically if you hold one side, you're allowed to spin the other. And even though they're connected, it will spin this other thing to release the energy. That didn't work because it's super bulky. It was about that big. I don't know if you guys saw it or not, but it was quite impossible with how many bricks we use for the structure of our catapult.
Does anyone have any questions?
Yeah.
While we're working on setting the program up? Show you that?
No?
Do you have any questions about anything?
I'm thinking.
Anything?
Yes.
Yes?
Did you break any pieces?
No. Did you?
No.
Did you guys just kind of design each part separately, or did you kind of do every separate part at the same time, kind of?
We had, each of us had a job. George had the loader, I had the winch, George had the claw, because he was a master at that. You had the claw. And you had just the programming and helping all of us out.
So the programming is quite simple. It's all in a continuous loop, so it would just fire over and over and over again. We weren't sure about how, for the presentation, how we wanted to trigger it, but it could be in a number of ways. We could easily have added a sound trigger or something like that to make it sound enabled. I just wanted to make it continuous just for the lack of what we need for the presentation. So on a continuous loop, we have both the A and B motors are working the winch at the same time, so we could get a faster, the winch operates pretty slowly all in all, even when everything's going 100%. It's pretty slow when it pulls down the claw, so we added the two motors to help out with that. We have a 3-second release, or a 3-second time delay for when the ball's released into the claw, just make sure everything's falling into place and everything, just kind of a guideline for it. This is the motor that operates the claw itself, which, as George explained, also activates a pull string, which pulls the motors off the winch. And then there's another 2-second delay until the claw goes back to its original place, the ball loader claw. And then we go back in the loop and just start winching it up again. It was rather easy to program it, and everything seemed to fall into place pretty easily. The only programming issues, or not issues, but the only programming, I guess programming issues to overcome was getting this had to be precisely 90 rotations. We figured that out with the gear ratio, and with how long, we actually measured out the string, and we found that it was exactly 7 inches that we had to pull this. 7 centimeters. 7 centimeters?
Yeah.
It was exactly 7 centimeters that the string originally had to pull, which gave us for the claw to come all the way down, and
We use that gear ratio.
the gear ratio gave us exactly the 90 rotations to when it came all the way down, and before we needed to release it. So it worked out pretty smoothly, honestly, with the programming this time. That's it, as far as programming.
Any question?
Other
Okay.
questions?
Yep, thank you.